Here's where it gets weird. The second anomaly is what truly sets 3I Atlas apart in the minds of a few researchers, and it's a feature even conservative astronomers might call bizarre if it's ever confirmed. The debate revolves around its light. The solar wind then pushes this material away, creating the iconic tail that always points away from the star. It's a fundamental law of cometary physics. Here's where it gets weird. Based on an analysis of its brightness, some scientists have proposed a startling alternative to a normal coma. They argue that the light profile isn't consistent with just sunlight reflecting off a dust cloud. This has led to the highly speculative hypothesis that 3I Atlas might have a forward-facing glow, a kind of teardrop-shaped cocoon of dust pointing in the direction of its motion. They argue the observed pattern is far more consistent with a model where a central light source within the object is illuminating a dust cloud from the inside out. Their math suggests the combination of outflowing dust density and light from a central source could perfectly explain the steep drop-off in brightness they observed. If this hypothesis were true, it would change everything. But this raises the ultimate question. If it's generating its own light, how? What natural process could do that? Loeb considered rare radioactive materials or friction, but dismissed them as highly unlikely. After dismissing these natural explanations as improbable, one possibility remained on the table for him. As Loeb himself wrote, 3I Atlas could be a spacecraft powered by nuclear energy. This cannot be ruled out, but requires better evidence to be viable. The idea is staggering. The glow isn't a natural comet, but perhaps the exhaust or waste heat from a functioning piece of technology. It's a hypothesis that sits on the very edge of science fiction, yet one that, according to a leading Harvard physicist, is an interpretation consistent with some of the data.